Hello students, again welcome to IIT PAL lecture series on vectors. You must have done lot of theory and seen some you must have seen some problems. So now here is a time to again use the theory into our problems or see applications of vectors through the problems. So let us start. Here is my first problem. Let G, I am denoting G, be the centroid of triangle ABC and G1 be the centroid of another triangle which is denoted by A1, B1 and C1. Okay. So, this is something that is given to us. Then we are asked to show that A1 vector plus B1 vector plus C1 vector is equal to 3 times G1 vector. Okay. So, some of the things to understand before we actually start the problems. You have been given two triangles in space. So, let us draw this way. Let us draw it this way. This is triangle A, B and C. There is another triangle. It does not matter what kind of triangle is this, right. So, A1, B1 and C1. Okay. Okay, 1 minute. Let me for A's of calculations or showing A's of geometric representation, let me use a similar notation. This is A1, B1 and C1. Okay. Then what is being said is, if I connect, if my initial point is A and terminal point is A1, that is, let my vector be in this manner. I start with this, join A1. Okay. Then I start with B. Let us slightly shift B. I start with B and join B1. Okay. So, let me erase this. Let me again draw, because the A1, B, B1 are not very visible. So, let us draw it this way. A, B, C. Let me take it slightly upward. A1, B1, C1. Okay. Then I start with A and join A1, that is this line. Okay. Then I start with B and join B1. Sorry, I start with B and join B1 this way. I start with C and join C1. So, as you must have seen, this has a direction in this form, A1, B1, C1. Then you must be knowing what is a centroid, right. The centroid is something that is, let me slightly zoom in. Okay. Centroid is something that is, if I start with this point and draw a line to the opposite side, it should bisect this opposite side into two parts, two equal parts. Okay. Similarly, if I do this for all the sides of the triangle, then I should get a point. And that point is called centroid. For this particular circle, this is for this particular triangle, this is the point G, which is the centroid. So, I will do a similar exercise over here. Okay, and this is a point G1 for me. this is a point G1. So, what is being said is, extend this to G1. Okay. So, what is being said is length of or the vector in vector notation A1 bar plus B1 bar plus C1 bar is nothing but 3 times G1 bar, and we want to prove it. Okay. So, simple thing is I will start with one vector A1 bar. Now, if I want to prove this has a if I want to prove that this plus some other vectors have the component of G1 bar, then I should express these component these vectors having component as G1 bar. How will I achieve that? I can achieve that very easily by considering the centroid. Is there any line that is coming to the centroid? Yes, there is a vector which is coming from A to G. So, I can write this as AG bar or a vector AG. Then if I want to go to the point A1, which is a point here, how will I go? I will, if I am here, then there is only one way to connect, that is G1 bar. So, I can write this as G1 bar plus, then if I want to go to A1 bar A1, then there is a vector of this form which is G1 A1 bar. Can you verify this? We have actually used a triangle law in an implicit manner, that is we started with AG and then we reached at G1. So, it is AG1 bar, and then we again used the triangle law which is AG1 bar plus G1 A1 bar, and therefore, we have actually moved from A to A1 bar. In a similar manner, we want a representation for B1 bar or vector B1. So, it will again be, now you can guess, it will be BG. I will come to the centroid of the triangle, again I will write this in terms of G1 plus I have to go from G1 to B1. So, G1 bar and then G1 B1 bar. Similarly, I can do a same calculation for C1 bar, which will be CG bar plus G1 bar plus G1, and the terminal point should be C1. So, this is a repeated application of triangle law, that is what I am demonstrating. Right. So, now if I sum all these three equations, I will get the left hand side. What is my left hand side? It is this. So, A vector A1 plus vector B1 plus vector C1 is equal to vector AG plus G1 A1 plus, so I can write this in short, but let me do it in brief. So, BG bar plus G1 plus G1 B1 plus you have CG G1. Okay. So, if you look at these three terms, you are getting a part of RHS, that is 3 times G1 bar. Let me erase this circle, so that it will not obstruct us, plus some remaining terms, and if what is to show is true, then I have to show that these terms are 0. So, let me write them in this form. So, it is AG bar. So, let us take these three terms together, plus BG bar plus CG bar. So, these are the terms which are of first triangle plus, let us take these three terms, G1 A1 bar plus G1 V1 bar plus G1 C1 bar. Okay. So, these are the terms of the second triangle. So, now if you look at this term AG bar BG bar plus CG bar in the context of the triangle, then let us name this point. Okay, so this particular term is AG bar, then we have BG bar which is this side, and CG bar. Now, if you look at this triangle has one intersection at this point, let us call that point as D. Then what we can see is BG bar plus CG bar using the section formula that is derived in the previous classes. We can write this BG bar plus CG bar as, so let me write it here, BG bar is equal to, so I have to relate this to D according to section formula. So, if I am dropping a line from this on the line segment BC, then I am cutting it internally, therefore, and it is divided into two equal halves, therefore, this should be 2 times DG bar, right. So, this is based on section formula, or in section formula notation we can write this as DG bar is equal to there is no 1 here, BG bar plus CG bar upon 2, right. So, I will use the same logic and I will write this term, that is this term, as 2 times DG bar or 2 times DG vector. So, overall our formulation now becomes GG1 bar plus AG bar plus 2 times DG bar plus, I can play a similar trick over this particular triangle. I will not explain it again, but you can guess what that trick will be. So, I have this and this GB1. So, there is a line which connects the points B1 and C1, and there will be an intermediate point D1. So, let us call this point as D1, and it cuts this into two equal halves. So, I will again apply that section formula and write this as 2 times G1 D1 bar. Okay. I missed one here. Okay. So, GG1. So, now it is fairly straightforward. Now, this is a centroid, G is a centroid. So, this point DG bar 2 times DG bar is nothing but GA bar. Okay. If you can see, this is a centroid. So, this length that is this length is twice the length covered over here, and it is in GD bar and AG bar, both are in same direction. So, GA bar is in opposite direction. Okay. So, this is AG bar plus GA bar. Similarly, this thing, it starts with G, ends at D. So, this will be A1 G1 bar by the same logic. Okay. So, now this expression can become AG bar plus GA bar plus G1 A1 bar plus A1 G1 bar, and as usual this is staying intact. Now, what are these? AG bar and GA bar are nothing but opposite vectors, that is Ag bar is equal to minus Ga bar, right. So, therefore, it will be 3 times G1 bar plus this will nullify the effect of this. So, essentially what we are starting with A, we are going to G, again we are starting from G, we are coming to A. So, this is nothing but A bar. So, this will be a 0 vector plus, say by same logic this will again be a 0 vector. So, 0 vector added, we will not get anything. So, it is 3 Gg1 bar, which is our nothing RHS, right. So, in short, we started with LHS. So, this was our LHS, which is this. Then we have split them into components using triangle law. So, these are the component wise divisions. Then we isolated this 3 Gg1 bar. Then we have used the properties of triangle. Here we have used the section formula, right. Same formula we used here also. Then after using the section formula, we have used G is the centroid, therefore, this thing is equal to this and this thing is equal to this, and therefore, we have proved the RHS. Okay. So, this finishes this problem. Okay. So, is it okay? Oh. Then you have seen lot of problems based on coordinate system, right, when earlier lectures on theory of vectors. So, let us come to the coordinate system and see some problems. So, here is a question. Let me choose a different color. So, here is a question. We have been given 2 points, or you can say position vectors of 2 points. Let P, Q, R and S be the points on the plane. So, in earlier lectures you must have seen that either we can give the coordinates of the point or we can give the position vector of points. So, here we are choosing to give position vectors of a points. So, plane with position vectors. So, position vector for P, position vector for Q and position vector for R and S. So, the position vectors are minus 2I minus j. I am following the same convention, I will not write I cap j cap. So, I am just writing I and j. For Q, the position vector is simply 4I. For R, the position vector is 3I plus 3j, and for S it is minus 3I plus 2j, okay, respectively. Okay. Then the question is very general. The question is, what kind of quadrilateral is PQ, R and S? Okay. So, this is the question, what kind of quadrilateral is PQRS? How to answer this question? So, there are few things. First, we have to generate the coordinate vectors PQ bar, QR bar, QR bar, then RS bar, then SP bar. So, these are the coordinate vectors that we need to generate. So, let us draw something, let us have some intuition about it. So, let us call this point as P, this point as Q, this point as R, and this point as S. So it can be any quadrilateral, right? So I don't, as of now I don't know what kind of quadrilateral is this, but I know something, that I can use my triangle law to obtain these, right. So I have been given a position vector, so all points are positioned with respect to my origin, which is O. So if I want to obtain PQ bar, you have done it several times, let me repeat it once. So this is OP bar, so OP bar, then you go dot 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 Q, okay. So OP bar is in this direction and OQ bar is in this direction. So so we want to find what is PQ bar. So here if you look at this diagram, then you will if you want to find PQ bar, then you will start with P, you will go to O, and then you will go to Q, right. So this can be mathematically expressed as OQ bar or vector OQ minus OP bar or vector OP, right. So remember this way, the initial point you will subtract the position vector, and the terminal point you will add the position vector. Same thing we can write for this. So initial point is Q, so you have to subtract the initial point, and terminal point is R, so you will add the terminal point. So this is a quick fix for this. So OS bar minus OR bar, and SP bar will be OP bar minus OS bar, correct. So now it is just a matter of adding and subtracting the vectors that are given to us. So what is OP bar? Let us write here, this is my OP bar, this is my OQ bar, this is my OR bar, and this is my OS bar. So we know all the vectors, I will not spend time in rewriting this. So OQ bar is 4i minus 2j minus 2i minus j, so it is 4 minus minus 2, so plus 2 times I, and minus OP, so minus minus plus j, okay. So this will be 6i plus j, okay. Then what should be the QR bar? Very easy, you can try. OR is 3i plus 3j and 4i, so only the addition is there in the ith component. So 3 minus 4, which will be minus 1i minus OQ bar. What is OQ bar? 4i, so there is nothing to subtract, but this has 3j, so it will be plus 3j, okay. So this is minus I plus 3j, okay. Similarly, what will be RS bar? Let me not do the calculation, let me leave the calculation to you. Minus 6i minus j, okay. Then what is SP bar? You can just verify, it will be I minus 3j, right, I minus 3j, okay. Now you can note few things. If you look at this particular expression, minus 6 minus j, and if you look at this particular expression, which is 6i plus j, then this is nothing but minus PQ bar, and if you look at this particular expression, I minus 3j and minus I plus 3j, again you are getting minus of QR bar, yes. So what we are saying is PQ bar and RS bar are parallel to each other, aren't we? In opposite direction. Similarly, Similarly, QR bar and SP bar are parallel to each other in opposite direction. So, if you have not done, these are unlike vectors, but and they are opposite vectors also, right. Okay. So, if they are opposite vectors, then what we have seen is they are parallel, right. So, one of the possibilities is because we are trying to address this question, what kind of quadrilateral is PQRS, these vectors are parallel. So, this quadrilateral can be parallelogram, but if all the sides are equal, then this can be rhombus. Okay. This is question mark, but one of the cases can be parallelogram. We do not know whether it is rhombus or not. It can be rectangle. For it to be rectangle, either the diagonals should be equal or one of the angles we have to show that it is 90 degrees. So, I do not know this, but for sure it will be a parallelogram. So, let us try to eliminate or justify the possibilities of rhombus and rectangle, right. So, what we will do is we will first find mod PQ. Okay. So, what is mod PQ? Now, this is nothing but square root of the coordinates 6I plus j, that means 36 plus 1, which is equal to 37, right. Mod PQ is 37. What is mod? So, we will just check the opposite thing, RS bar, which is equal to, again only with a negative sign. So, it will be 36 plus 1 again. So, this is again equal to 37. So, it should be square root of 37. So, what we have again shown is PQ bar is equal to RS bar mod of. Similarly, we can do the other part, that is QR bar is equal to SP bar. Okay. So, again this ascertains that this is a parallelogram. Now, take PQ bar dot QR bar. Now, we want to see whether they form an angle of 90 degree or not. How will we ensure that? So, if we have two vectors, say A bar and B bar, and if you are sure that they form a 90 degree angle, then this product should be equal to 0, right. If A bar is perpendicular to B bar, this product should be equal to 0. So, we will check whether the product is equal to 0, whether the angle Q is 90 degrees or not. Okay. So, what is P and QR, that we have to see? 6I plus j, slightly I will shrink. So, it is 6I plus j into QR is minus I plus 3j. Yesterday or in the last class or few classes before this class, we have seen this component wise multiplication, right. So, this is 6 into minus 1 plus 1 into 3, which is equal to minus 6 plus 3, which is 3, right. 1 minute. It is not 3 because minus 6 is there. So, it is minus 3. Okay. Similarly, you can check for all other things. So, I will just write down what are they: QR bar plus RS bar, it should be equal to 3. Then this also should be equal to SP bar dot PQ bar, and then only one thing is remaining, which is RS bar dot SP bar, which is equal to minus 3. Okay. So, you can notice some common thing that is going on. First of all, they are not perpendicular to each other. So, this cannot be a rectangle, that question is eliminated. Okay. Then PQ and RS are same, QR and SP are same, but let us evaluate one, let us say QR bar we will evaluate, mod QR bar. So, what will it be? Let us see what is minus I plus 3j. So, it will be 1 plus 9 under root, which is equal to root 10, and this is not equal to root 37. Therefore, all the sides are not equal. So, this is equal to mod of PQ bar. So, all the sides are not equal. So, that eliminates, it cannot be rhombus, it cannot be rectangle, because the none of the angles is rectangle possibility is also eliminated. So, only thing that remains is parallelogram. Therefore, quadrilateral PQRS must be a parallelogram. Okay. So, this is the conclusion of this problem. Okay. Now, let us go to the next problem. Let us try to again come to a triangle and show something. So, the next question is prove that the vectors the vectors 3i plus 5j plus 2k. Since it is a triangle, I will deal with 3 vectors 2i minus 3j minus 5k and 5i plus 2j minus 3k form sides of an equilateral triangle. First of all, we should show that they form a triangle, and then we show that they form sides of equilateral triangle. So, for brevity, let us write them as A bar. So, this is the question. Now, we will start with the answer. A bar is equal to 3i plus 5j plus 2k. B bar is equal to 2i minus 3j minus 5k. Okay. Let us just name these two. I have one interesting observation. If A bar plus B bar, I sum it together, then you just see 3 plus 2 5i, 5 minus 3 which is 2j, 2 minus 3 which is minus 3k. What is this? This is nothing but this. So, this is nothing but C bar. I will call this as C bar, and therefore, these 3 vectors form a triangle. Okay. Now, we want to show that they form an equilateral triangle. There are 2 ways to show. Either you show all the sides have same length, or you show all the angles are of measure 60 degrees, right. So, we will choose the latter one, because we have an opportunity to choose the dot product. So, what is A bar dot B bar? It is very easy, it is component wise. So, 3 into 2 6, 5 into minus 3 which is minus 15, and 2 into minus 5 which is minus 10, right. So, that is 6 minus 25 which is minus 19. Okay. Then A bar dot C bar, what is it? Again it is again very easy to show. So, you just take C bar 5 into 3 15, 2 into 5, 10, minus 3 into 2, 6, 19, then what is left, B bar dot C bar. These are the three angles that we have to check. So, B bar dot C bar, what is it? Just check, 10 minus 6 plus 15, which is equal to 19. That means all angles must be same, right. So, now in order to say in order to find the angles, we also need to find mod of A bar, right. So, what is mod of A bar? That is A bar dot A bar. So, let us write mod of A bar square, does not matter. It is 9 plus 25 plus 4, which is equal to 38. Similarly, since it is just a permutation of all the numbers, so this also must be, all the vectors if you see are permutations of 3, 5 and 2 with positive or negative sign. So, this also must be 38, and similarly this also must be equal to C bar square, isn't it. So, now let us go to our dot product. Now, if I want to find angle between the two vectors, say cos theta, A bar dot B bar upon mod of A bar into mod of B bar, or magnitude of A bar into magnitude of B bar, which is equal to minus 19 upon 38, which is equal to minus 1 by 2. Similar, let us call this as theta 1, cos theta 2. If you do similar calculations, this will become 1 by 2, cos theta 3 will again be equal to 1 by 2. So, cos theta 1 is an angle between A bar and B bar, and all others are angle between. So, let us call this as A bar, let us call this as B bar, let us call this as C bar. Okay. So, this angle, because A bar and B bar are being considered, they cannot have angle here, they will have angle here. You can shift A bar here and they will have angle here. Then what is theta 2? Theta 2 is an angle between A and C, which is this, and then an angle between B and C. Okay. So, you just see cos theta is equal to half, that means theta is equal to 60 degrees. Okay. So, these are the angles which are 60 degree angles, but between A bar and B bar you are getting a negative number. So, this must be an obtuse angle, and therefore, it is cos of 120 degrees is equal to this. But for triangle we are not considering this angle, we are considering the angle 180 minus theta 1. Okay. So, which is nothing but 60 degrees. Therefore, this angle is also 60 degrees. Therefore, what we have shown is all sides are same and all angles are same, which are 60 degrees. Therefore, this must be an equilateral triangle. So, this must be this can be an abbreviation of triangle. Okay. Okay. So, now let us analyze this problem. So, we wanted to show that some position vectors are given, and you wanted to show that this is an equilateral triangle. A bar plus B bar is equal to C bar shows that this is a triangle. Okay. Then if we are interested in shortcut, you need not prove this, because the moment you say all sides have equal magnitude, you get an equilateral triangle. So, it is A bar B bar equal to C bar, therefore, this is an equilateral triangle. In addition to this, what we have done is we have figured out what are cos theta 1, cos theta 2 and cos theta 3. Here the main purpose of showing this is, even though this number is negative, this angle is not considered for the formation of triangle. That is what I wanted to emphasize. So, I have shown you this method. So, in particular, if you just want to show something is an equilateral triangle, first it should form a triangle and you have to show that all sides are equal. It suffices to prove this is an equilateral triangle. Okay. So, let us move on to the next problem. Okay. So, let me move on to the next problem, and let us take some simple problem now. Let us take another problem on triangle, which you are very much familiar with, and this time we have an isosceles right angled triangle. So, let us say show that okay, show that points. So, you see we are switching between position vectors and points. Points A -1 6 6, B -4 9 6, and C, which is 0 7 and 10, form an isosceles right angled triangle. Okay. So, again we do not have much time left. There is a one-to-one correspondence between this representation and the position vector representation. So, I will directly write what is A B bar, and I want to show that this forms a triangle also. So, first here are three things that I have to show. First, this forms a triangle. Isosceles means two sides are equal and some dot product is equal to 0. So, let us write A B bar is equal to O B minus O A bar. So, that will be minus 3I plus 3J. So, you can just verify -4 minus 1, which is +1, this is this, then 9 minus 6, which is 3J, and 6 minus 6, which is 0. Then I will have AC bar, which is equal to I plus J plus 4K. Okay. This is AC bar. Then the left is BC bar, which is equal to 4I minus 2J plus 4K. You can do it quickly in your mind and verify my results are correct. Okay. Also, you can see AB bar plus BC bar is equal to AC bar. Can you see this? AB bar plus BC bar, minus 3 plus 4, which is I, 3 minus 2 is 3 minus 2 is 1. So, this is J, and there is 0, 4, this is 4. Okay. So, AB bar plus BC bar is equal to AC bar. So, this ensures that the triangle is formed, or we have again used the triangle law. Okay. Now, we want to show that there is this triangle is isosceles. That means two sides are equal. Can you guess which two sides are equal from this representation? Okay. So, I guess these two sides are equal. Why? Because you square each term and see if it is happening. So, it is like AB bar is equal to what? 3 square, which is 9, plus 3 square, which is 9, and root of that. So, that is square root of 18. What is AC bar? is equal to 1 square, which is 1 square, again 1, 4 square 16, root of that is equal to root 18. So, this is just by inspection I have seen, and therefore, my AB bar is equal to AC bar, right. So, I have shown it is a triangle, it is nothing but isosceles triangle. Now, I have to show that this particular triangle is right angled. Now, you can see A both are initial points. So, the angle at A must be a right angle, right, because these two sides are equal. So, suppose I want to draw this figure, right, the sides are equal, and if the sides are equal, then that definitely cannot be hypotenuse. So, it should be BAC, right. So, if these two sides are equal, then the angle at this point must be a right angle. Let us verify the claim. How will we verify the claim? We will just take the dot product of these two sides, AB bar dot AC bar. So, we have the coordinates. So, we can just it is a component wise multiplication, minus 3 plus 3, and there is no component of k. So, it is 0 k. So, it is 4. So, this is nothing but 0. So, hence the claim is verified. Therefore, it is right, therefore, triangle ABC is right angled at point A, correct. Therefore, what we have proved is triangle ABC is a right angled isosceles triangle with right angle at A. Let me not write that. Okay. This proves our hypothesis. Okay. Let us take another problem on vectors. So, here is a problem. The problem is, if I have been given a magnitude of 3 vectors, for example, magnitude of A is equal to 3, magnitude of B is equal to 1, and magnitude of C is equal to 4. Also, I have been given a condition that vector A plus vector B, the vector addition, is equal to 0. Then I want to find the value of dot product, right, cyclic dot product, A bar dot B bar plus B bar dot C bar plus C bar dot A bar. So, this is an interesting observation. First, you just take A bar plus B bar plus C bar. So, I am basically solving this problem. So, solution, this is equal to 0. So, if I take a dot product of this with A bar plus B bar plus C bar, what will be the answer? 0 into 0 is 0, right. How did I get this concept? Because I need these cross terms. So, in order to generate the cross terms, I need to take something like this. Then what I will come up with? I will come up with A bar dot A bar plus all the terms which are same, B bar dot B bar, C bar dot C bar, right, plus all the terms like A bar dot B bar, A bar dot C bar, all of them will come twice. So, it will be 2 times A bar dot B bar plus B bar dot C bar plus C bar dot A bar, and which is equivalent to saying A bar dot C bar, because this is commutative, dot product is commutative, right. Do I know anything about this? Yes, I know this a bar dot a bar is nothing but mod of a bar square plus magnitude of b bar square plus magnitude of c bar square plus 2 times all these terms as it is correct. Now, what are these terms? Magnitude of A is 3, so it is 9 plus magnitude of B is 1, so it will be 1 intact. C is 4, so it will be 16 plus 2 times A bar dot B bar plus. So, I think essentially I have solved the problem. Then you just simply manipulate this term. What is this? This will become I think 26 and 26 plus 2 times this bracket. This bracket is nothing but the term that we are expecting, right. So, I will not rewrite the bracket. So, this bracket is actually equal to minus 26 upon 2, is not it. So, this is equal to minus 13. So, our answer is a bar dot b bar plus b bar dot c bar plus c bar dot a bar is equal to minus 13. This is our answer. To summarize today's lecture, what we have done is we have used vector algebra efficiently to solve some of the problems typically related to geometry. Then we have used our scalar multiplication in order to show something is perpendicular or not. Basically, we have used a property that the dot product of two vectors is 0. Then if the vectors are non-zero, the angle between them must be a 90-degree angle. Also, we have shown some problems related to triangles where one of the angles was an obtuse angle, but that angle was not used while forming the triangle. So, you have to be aware of all these things when you are solving the problems. So, let us see you next time, and we will solve some more advanced problems related to vector algebra and scalar product. Okay. Thank you for watching.